Peptides coming at you during the coronavirus pandemic. A little fun fact: pandemic. If you don't know what that means, you hear them saying on the news, whatever. It means a disease or virus that has gone across multiple continents. You know, like Africa, Europe, North America, or gone throughout the world. That's what pandemic means, and that's what we're in right now. And that's why y'all get to look at me on the internet instead of real life. But hey, we'll get it done, right? So today's notes is Learn Target 1. I know you can't see this, okay, but these notes right here, right, are on hidescience.org. So if you want your own little thing to look at, it's on there. Go check it out. It's under the Notes Study section of Unit 7 on www.hidescience.org. All right, so basically what we're doing, we're looking at a couple things. We're reviewing the atom, just the basic atom. We're going to talk about isotopes. We're going to talk about ions, just to review real quick. Then we're going to talk about transmutation just a little bit, run through all that. And that'll be it for today. Throw about one or two more new vocab words at you, and that'll be it. So, in reviewing, okay, so we have a couple things available to us. So this is like three things off the periodic table, right? On order. So we have these top numbers here, 7, 8, 9. What this number is a dead blue marker. No, a dead blue marker. Okay, this is going to be our atomic number. Okay, what this atomic number tells us is it tells us how many protons there are every time, all the time, no matter what. Protons don't change. They cannot change unless we'll talk about it later on. But if we're going to have nitrogen, nitrogen's going to have 7 protons. That's it. It's just going to have 7 protons. Don't worry about it. It's going to have 7. Okay? And that's what this number tells us. Now, this number tells us, let me get down here, also tells us that the amount of electrons most of the time. If we're dealing with ion, it don't work. But it does work most of the time. Right? Now, we also have the symbol, the name, and here, this is our atomic mass. This number tells us the total things in the nucleus. So, what's in the nucleus? Protons and neutrons. So, it's going to tell you how many total are there. So, if we're trying to calculate neutrons, you're just going to subtract them. So, real quick, we're going to run through a couple things. We're going to learn how to find, protons, neutrons, electrons, valence electrons, and energy levels. I know my handwriting is gorgeous, right? So protons, neutrons, electrons, valence electrons, and energy levels. So first things first, protons. Again, atomic number right there, no matter what, tells you. Don't get it screwed up. Don't get it mixed up. Just go to the atomic number, right? So nitrogen would have 7. Oxygen is going to have 8. Fluorine would have 9. Can you see that? Can't see that, can you? All right, I'm just going to stick to black. Now, most of the time, we're not dealing with ion here, so most of the time, our electrons are going to match our protons. These positives and negatives are going to balance each other out. They're going to cancel each other out. So, 7, 8, 9. Now we get to neutrons. All right, so neutrons, are going to use this mass number. So the mass is 14. There's 14 total things in that nucleus. Well, we already know that 7 of them are protons. So how many more must there be? So for this one, we'll do 14 minus 7, okay, which is 7. For this one, we'll do 16 minus 8, which is 8. For this one, we'll do 19 minus 9, which is 10. Now, if there's a odd number like decimals, you're going to round, same rounding rules as the rounding rules, right? Valence electrons. This is based on what group it's in. So nitrogen's in group 15. We'll cover up the 1 here, right? It's going to have 5 valence electrons. And that means electrons that are in the outermost energy level. Oxygen's going to have not 16. Can't have 8. So it's going to have 6. Fluorine, nope, not 17. You're right, 7. And energy levels is how many rings of electrons are there around the nucleus. So all 3 of these happen to be in row 2. So there'd be like a 2 way over there on that side, telling us in the second row. So they're all going to have 2 energy levels of electrons. That's it. That's the review of the basic atom. Rock and roll. Isotope. We talked about isotopes 500,000 times. I'll talk about them again though. All right, so isotopes, I-S-O-T-O-P-E. All right, isotope is just an atom. It's just a version of an atom. You got fat atoms, you got skinny atoms. We just call them isotopes, right? It's a little nicer than saying, hey, that's a fat atom, or saying, hey, that's a skinny atom. But we just say, hey, that's an isotope atom, right? It keeps them from getting their feelings hurt, and that's important. So we'll just use fluorine. All right, so if I was to ask you to find, F or fluorine, if this is what you saw, this is just talking about regular old fluorine, just normal, not fat, not skinny fluorine, just fluorine, right? But what if we want to talk about isotope of fluorine? All right, so we would see something like this. Okay, see something like that. That tells us, hey, that's probably isotope, or something like this. Again, it's like, hey, probably isotope right there. Protons, mass, mass. Two ways of writing it. So fluorine always got 9 protons, no matter what, right? As long as we ain't talking about no ion, it's got 9 electrons too. What's different about isotope is neutrons. All right, so usually, like we did a while ago for fluorine, you would do mass of 19 minus 9, you would get 10 neutrons. But in this case, our mass is 20, right? So we'll do 20 minus our atomic number, right? Same thing, 11. So this has 11 neutrons, not 10. This is fat fluorine. Don't tell them I said that. We'll just call it isotope, okay? All right, over here we got fluorine. 8. So this is our mass over here of 18. So we're not going to use this mass. We're going to use this mass. Right? We still use the same protons. Fluorine's always got the same amount of protons. So this one is going to have 9 neutrons. So this is the skinny version of fluorine. Right? They're just isotopes. They're just heavier or lighter because they have different amounts of neutrons. They have different amounts of neutrons, then the total amount of things in the nucleus, atomic mass, cannot be the same. It's got to change, right? It's like gaining weight. If you gain weight, you can't weigh the same you always weigh. You got to weigh more, right? You go on a diet, you eat less, drop your calorie intake and all that, and you lose weight. You can't weigh the same if you lose weight, if you get skinnier. It doesn't work. All right, so that's isotopes. Up next, ion. All right, this is a charge, right? So if we have an element number like oxygen, if it's an ion, there will be a charge in that area telling us that it is an ion. So oxygen, right, has 8 protons, 8 neutrons, 2 electrons here in the first level. In the second level, right, has 1, 2, 3, 4, 5, 6. Okay, so that's one version of this. I'm gonna draw. This is a non-metal. I'm gonna draw us another metal one too. Sorry, my handwriting's so beautiful, you might not be able to understand it. Just work through it. All right, the next one would be. We'll do a metal. I'll do another magnesium. Right. So magnesium has 12 protons. It has 12 neutrons. It has 2 electrons in the first level. It has a full 8 in the second level. And it has 2 out here in the valence level. So our valence electrons are here. Okay, these are all our valence. An ion is going to make a move. It's going to make a move so that it can become stable, so it can be like them noble gases that everybody wants to be like them noble gases and have 8. So that's what's going to happen. 2 ways it's going to do. It's going to fill up the shell that's in, or its valence shell it has now, or it's going to drop it. That's it. It's going to fill it all the way up, or it's going to drop the whole thing. Okay? So it depends on what is easier to do. Right? I ain't going to do the hard thing. I ain't going to do the easy thing. So in this case, we have 1, 2, 3, 4, 5, 6 for oxygen. Well, to fill that up, it just needs 2 more to get to 8. 6. We got 6, 7, 8. All right. We need these 2. That's all we need. We need 2 more. Right. So It's going to bring in an electron here, right? And it's going to bring in an electron here. Now it's good. Okay, but because of doing that, it throws the balance of positives and negatives off. Right? We had, to start originally, we had 8 protons, 1, 2, 3, 4, 5, 6, 7, 8. And we had 8 electrons. Right? But we added 2 electrons. Okay, this gives us 2 of these. Right? So our total positive charge for this is positive 8. And our total negative charge, if we add them all up, is now negative 10. Right? If we combine that, our overall number is negative 2. Right? Or if we kind of cancel them out, 1, 2, 3, 4, 5, 6, 7, 8. We got 2 negative charges left over. So this is going to be oxygen negative 2. By gaining those 2 negative electrons, we have a negative charge. Now over here, magnesium is a little bit different ball game. It's a metal, right? So, just to kind of go back, a negative ion is called an anion. Just is. Deal with it, right? So magnesium has 2. Right? So to fill that up to 2 to get to 8, we have to go 3, 4, 5, 6, 7, 8. That's too much. Let's just drop it. Okay. So we're going to drop this whole shell. Right? And by doing that, we got 1, 2, 3, 4, 5, 6, 7, 8. We're full, we're stable, we're good to go. We got 8 valence electrons. Life is good. All right, but yep, we threw off our balance between protons and electrons. Before we started, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had 12 positives. We also had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 negatives. But we got rid of that valence shell. We dropped 2 of them. So now we got 10 negatives. Okay. If we combine this number, we'll get positive 2. If we cancel them out, hopefully, if I drew them out right, we get positive 2. So this is magnesium with a positive 2 charge. And again, I taught you all the trick. We can just be like, it's group 1 will be plus 1, group 2 plus 2, group 13 plus 3, plus or minus 4, minus 3, minus 2, minus 1, 0 on top of the periodic table. All right, last thing. Transmutation means change from one thing to another. Change the identity from one to another. Very simple. So we talked about neutrons. We talked about electrons. What's coming next? Protons. So if I have nitrogen, or let's say I have oxygen. We'll start with oxygen here. Okay. Oxygen has a mass of 16. It has 8 protons. Let's say somehow went up to the sun, and I got the sun. I threw that oxygen in there, right? And that oxygen slammed a hydrogen into it so fast that it just went right in that nucleus. Right? All a hydrogen is a proton, right? It's got a mass of 1 with 1 proton. So there's 1 total thing in the nucleus, and that 1 thing is a proton. So if we slam that hydrogen in there, we add a proton to this. So now we have 9 protons, and we have a mass of 17. This don't matter. This is just isotope, fat, skinny stuff, right? Who cares? This matters. This means we are no longer oxygen. We are now fullerene. And that is transmutation. All right, one more. Okay, one more. Let me put a marker up. Grab me a blue. Let's do a blue one. All right, let's say we still have oxygen. Right? But for some reason, somehow, this oxygen came unsteady, whatever. It lost a proton. Remember, hydrogen is just a proton. It lost a proton. We'll talk about that happening a little bit later on. So now, 8, it lost a proton. Now it's got 7. It had a mass of 16. It lost a proton out of there. Now there's only 15 things inside. Again, this don't matter, it's just fat, skinny stuff. This means we are now nitrogen. Something else to come means is the law of conservation of matter. Just must mean we just have equal stuff on both sides. So, if we separate the equation, we're on this side. This is like the before, okay? This is the reactants. They react together to form the products, which is the after. So over here, I have a total mass of 16 plus 1. I have a total mass of 17. All the law of conservation of mass says is that I must have an equal mass on each side. Here I have a mass of 16, right? So over here, I have a total mass of 16 too. We'll get a lot more in detail on that. I just thought it was a good time to bring it up while we brought this up. All right, so base atom, ions, isotopes, transmutation. You should be pros by now. I forgot. I told you that a negative ion is an anion, but I did not tell you that a positive ion is called a cation. Now, for some reason, they think that you're going to remember that by remembering this. And I'm going to tell you, and maybe it works for you, but it's kind of crazy. Cations are positive ions because, are you ready for this? Are you ready for this? Cats have paws. And on that note, I'm out.